Hey everybody, my name is Marcus. I lead the AI research team over at Vaadin. Vaadin is a company that helps Java teams build web applications. In my team specifically, what we're doing is we're looking at how AI being included in applications is changing the UI patterns that we have when we're interacting with computer systems. So in today's talk, I want to take a look at some practical AI patterns that I see emerging, places where we can use AI today to really improve the user experience of our end users. I think that most of us here are building some sort of enterprise or business applications. These aren't the cool apps that you find in the app stores, but these are the apps that are running in the back of the office. They're what actually makes the business work. They're what makes the money that makes the world go round. So they're very important applications. But at the same time, working with customers over the past 20 years, I've noticed that there's a lot of inefficient workflows happening there. There's a lot of tedious work. And what I believe is that if we apply AI the right way, we can really improve the user experience of these applications while we're making the applications more efficient, the workflows more smooth. Now, at this point in time, there's a really tremendous push for just including AI in every single thing that gets built for just the sake of having AI. I'm not a big proponent of that. I think if there is a problem that can be solved programmatically, that's probably going to be the better way to go forward with that, just as it has in the past, because that's very deterministic. We can easily test it and make sure that it keeps working the same way over and over again. At the same time, AI has opened up a lot of possibilities for us to solve problems that just a few years ago would have been entirely impossible, or at least would have required significantly more kind of effort and resources for us to get working. So I think there's a lot of really cool stuff that AI has enabled us to do. In this talk, I want to show you that AI is more than just this common ChatGPT type chat user interface. They are very powerful user interfaces and they allow us to do a lot of things, but at the same time, they're among the most difficult to get right because the user has almost infinite possibilities of typing something in there, and we need to somehow process it and behave in the right way. In this talk, I want to also look at those perhaps less obvious ways of using AI, where behind a button click or a user action, there's AI running in the background. The user of the application might not even understand that there's AI happening, but it's allowing us to do things that we wouldn't have been able to do as easily in the past. So let's take a look at some code and really go through some practical use cases where AI can help us out when we're building business applications. All right, so I've prepared a little example application for us to walk through these patterns. And I'm going to share the link to the GitHub after the demo so you can get all the code from there. The project itself is a Maven-based Spring Boot project. I've added a few dependencies to it. So first of all, I've added Vaadin for us to build the UI. Vaadin is an Apache licensed open source framework, so everything you see here you can use for free. I've also added the Spring AI OpenAI dependency here, which is going to allow us to call OpenAI through Spring AI. I've added the Spring AI Tika document reader, which is going to allow us to read things like PDF documents. And in addition, I've added a database and JPA. We're not going to take a look at the implementation of those, but just so you know what we have to work with here. In order for us to start this, we need to define a API key for OpenAI for this to start. So in my case, I have my key in my environment as an environment variable, so I just pass that in here. But make sure that you put that in before you start using this. All right, so let's take a look at the very basics of how do we call an AI. So for that, I built a simple UI where we have the message input here, and when we say something like hello and hit send, it's gonna give us an answer. So the way this looks in code is that we first of all have a view that's mapped to the empty route here, so that's the base route that we have, and it's extending from Vaadin's vertical layout. I've injected a Spring AI chat client builder into my constructor here, and I'm using that builder to build a chat client. There's a lot we can configure here, and we're going to take a look at that in some of the future examples here. But for now, this is just going to give us the very basics of a client that we can use to call OpenAI. For the UI itself, I've created a message input and a list where we can just put all the messages that we have. And finally, I've added a listener for whenever a new message gets sent. So whenever that happens, we pull the value for the message out of the event. We create a markdown message that's going to contain the answer from the bot, and then we append two messages to the list. So one is the message that we just sent ourselves, and then the response. To get the answer, we'll prompt the chat client, passing in the user message, which is again from the event. Gonna call, hit call, and then finally say that we want the content from that. Usually LLMs will return answers in Markdown, so we're gonna set the Markdown of our Markdown message to that answer, and that's gonna give us what we have here. Now, in a lot of cases, you see these chat UIs having a streaming UI, where as the chat UI is getting its answer, it's going to, like a word at a time, draw those out. That's something that we can do quite easily with Vaadin as well. So we're going to change this a little bit from that. So instead of using call here, we're going to call stream, and we're going to get the content, and we're going to subscribe to that. So we're going to get essentially one token at a time, and we can then decide what we want to do with that. In this case, we can just say that we want to take our markdown, our response, and we're going to append markdown async to it. And we're just going to take that token and append it to it. And sure, we can place it with a method reference like that. All right, so I'm going to save. I am using HotSwap, so it's going to automatically apply those changes. The one thing we need to do in our Vaadin application for this to work is we need to make sure that we have the push annotation configured here on our application and implementing app shell configurator. So if we do the same thing now and say, hey, it's going to initially just show both and then stream the answer here. So pretty straightforward. We're going to use this pattern going forward. Now, before we move further, a couple of words about prompting. Prompting is how we talk to an LLM, how we give it instructions. It's not exactly the same as programming, although there are some similarities. First of all, we want to be as specific and clear as possible. So if we're being unclear with what we're asking for, it's not going to be able to give us very good answers. So let's say we say something like, how do I make the clicky thing do stuff? It's probably going to have a hard time giving us a helpful answer on what we're actually interested in. So it's probably going to make an assumption of what we want to do. Yeah, it's guessing that we're probably going to want to do something with a button. So it's going to give us some different opinions. So we might do it in HTML and CSS, or JavaScript, or mobile using Swift, or desktop application, or something else. So because we're being very unclear with what we are asking for, it's not going to be super helpful. If we ask something like, how do I listen for button clicks like this, we're being more specific. We're specifically saying that we're interested in buttons, so we're being a little bit more specific. But again, we're not being super specific, like what kind of buttons are we interested in. So we probably want to give it also some context of, like, what is the context that we're working within. One really good way of doing that is by giving a system message. So that can kind of ground your AI conversation in a specific context. So here, where we're using the builder, we could actually go in here and set a default system message like help the user with their Vaadin development questions. All right, so now hopefully what's going to happen is that it understands that any questions that we have will be within the specific context of Vaadin development. So how do I listen to button clicks? It should now hopefully give us a much more specific answer that's relevant within our context, which it does here. So that's going to be super helpful. If you're working with bigger tasks, it's always good to kind of break those down into steps. Say, like, hey, do this first, do that. And if you're doing something where you don't necessarily have good context to give, but you might be able to give it a couple of examples of, like, here's what I expect you to do, that's also going to be helpful. And finally, maybe the most important one is that you're rarely, if ever, going to have the perfect prompt the first time around. So what you want to do is just keep iterating. Just try a prompt. If it doesn't work, just restart, try something else that's slightly tweaked, and until you kind of get something that works. And that's going to be really helpful when we get to our next prompt here. So as we're going from this very open-ended chat interface to a more kind of specific task, like in our case, a document analysis, we can kind of work as much as we want on the prompt to really try to make it as good as possible. And whenever the user actually uses this system, all they need to do is provide a document in this case, and they're going to get an answer that's using that prompt that we've spent some time working on. In their view, they might not even understand that they're using AI under the hood. So in this case, I'm going to use a little simulated sprint planning minutes document where we have a sprint planning, and we want to just get the most important parts of it. So we have an upload component here, and we can select whether we want to summarize or identify action points. So in our case, let's say we want to summarize this. We're going to upload the document, and hopefully it's going to then go through that document and summarize the most important things. So what's the project, what's the date, what's the review, what are the priorities, key actions, and so on. So pretty helpful if we missed the meeting and we just wanted to get some insights there. Likewise, if we just were interested in understanding like what were the action points that were kind of handed out during this meeting, we could ask it to do that. And again, it'll process the file, and hopefully it'll give us some actionable things. So here are the different things that were decided, who they're assigned to, and when kind of they're expected to be done. So let's take a look at how I implemented that. So here I've created two different system messages depending on what we're trying to achieve. So one is for summarizing, where we ask it to create a concise paragraph and being clear and informative, and use bullet points and numbered lists to make it really skimmable and focusing on facts and figures. And likewise for action items, we're saying that, hey, provide a list of action items. They should be clear, specific, actionable, and have a person assigned to them, and so on. The actual UI itself is fairly straightforward. We're using a Vaadin upload component, and we're adding a succeeded listener to it. So whenever we get a file uploaded, we're going to call this parse file, which is going to use that Apache Tika file reader to read the content, and then finally pass the actual text content to this analyze file where we're actually doing the thing. So again, we're using our chat client, which will then get one of those two system messages to kind of give it the context of what it's expected of it. And then we're going to say, here's the text to summarize, and just pass in that content. And whenever we get the markdown, then we'll just add that to the website the way that we did here. So again, fairly straightforward. What was nice here is that we're able to kind of pre-bake these system messages, and kind of we could spend some considerable time tweaking them and making sure that they're really doing what we want. And to the end user, they're not visible. So they don't necessarily need to have the skills in prompt engineering to be able to use this effectively. All right, so let's take a look at another use case. In this case, we're working at a pizzeria, Bob's Pizza, and we get a bunch of reviews here, and we're very busy, so we don't necessarily have time to react to all of them. So it'd be very convenient if we could analyze the sentiment in these reviews. So in this one, I've implemented a way for using an LLM to look at the sentiment of each review and then assign it a positive, negative, or neutral tag like this. So this makes it easier for us to find perhaps the more kind of negative feedback out there and respond to it. In order to help our customer service representatives here respond to tasks, we created a little helper where it uses an LLM to pass in the feedback and provide a kind of a starting point, a little draft template of an email for answering that. So in this case, Lisa is not impressed with the bland pizza, and then in the response, we're like specifically referring to her concerns there. Now, this is probably a little bit too kind of short, kind of long and formal for what we're looking for here, so we might want to tweak the prompt a little bit further. but it does a fairly good job at what we're interested in doing. So let's take a look at how this is implemented. So again, we're in a Vaadin view, and we're using reviews that we have stored in a repository. So that's just a plain Spring JPA repository. What's interesting here perhaps is just how do we do that sentiment analysis. So if we look at that, we'll see that the analyze review looks something like this. So we're using, again, our chat client. We're doing a prompt. What's different here is that instead of just passing in a user text message as an entire text, we're using this lambda here, and we're able to kind of assign different parts of it. So instead of just passing a string, I'm going to use a template and saying that analyze the sentiment of the following review. I'm going to give it a placeholder here, and then I'm going to pass in the review itself as a parameter. The other cool thing is I'm going to say that instead of getting the content, I say that I want to get an entity, which is of type sentiment response, which is this record that I added here. And the sentiment is an enum, which has those values that we have. So that way I can ask Spring AI to automatically turn the response into a format that's going to be much easier for me to work with in Java. All right, so the other interesting part of the UI here is how do we draft that response? So again, we're doing the same thing. We're creating a prompt. We're giving it a system message that lets it know that it's a customer support representative. We could communicate in a friendly and respectful manner. We could tweak this to be a little bit more concise, and maybe kind of tone of voice should be different from what we're having. But for now, it's going to be good. So again, we're using this lambda here where we're able to pass in the text as a template. So we have the name and the review, and then we pass in those parameters there. And in this case, we're not streaming or getting an entity. We're just getting the string content that we're then displaying in our view. Right, so fairly straightforward. None of these are very kind of mind-blowing on their own. What's kind of interesting and what I want to kind of highlight with this is that AI can be so much more than just that chat interface. And often I see that some of the more kind of powerful AI-driven features might not obviously be AI-driven features to the end user. So let's take a look at a kind of a very different approach where we actually have a sign-up sheet from a local Java user group like this, and we've collected some names and emails and t-shirt sizes, and we want to digitize these so we have an easier way of keeping track of people. So what I did here is I again have an upload component here, and we can drag in the sheet here. And what we're going to do is we're going to extract the data using an LLM, a multimodal LLM in this case, and get that in a format that we can display in a grid. And that way we can kind of sort and filter and take a look at all the content that we have here. What's perhaps remarkable is how similar this is to everything that we've done so far. So what I've done is I've defined records for everything that I want to extract. So I have a sign-up sheet, which is a list of participants, and each participant has a name, company, email, and t-shirt size. So it matches what we have here in our document. Then again, we're using an upload component, and we're adding a upload succeeded listener on it. And when we get that sign-up sheet image, what we're going to do is we're going to call the client to prompt. We're going to give a user message saying like, hey, please read the attached event sign-up sheet image, extract all participants. We're going to add a second part to the message, which is the media. We'll parse the MIME type from the image, and then we pass in or create a resource based on the input stream that we have. And then the kind of magic part here is that we use this toEntity, which will then inform the LLM in which format we want the data. And as you can see, it does a remarkably good job at extracting data from just handwritten text on a paper in this case. So you could imagine how this would be useful for all kinds of form digitizing or receipt scanning or anything like that. Once we have this, all we do is we call show participants, which then just kind of sets the items in our data grid to a array list of all the participants like this. So again, maybe the kind of most remarkable part of this is how similar it is to everything that we've been doing so far. All right, let's keep on going. So in the next example, I want to take a look at calling tools. So it's really fun that we're able to kind of do all these calls, but where the power really lies is when we can have the LLM be able to call some tools in our system to fetch some data or interact with our system. So in this case, I have kind of a simulated database of different products and a chat where I can then interact with that database and ask for some things. So let's say like, give me info on ID 5 in this case, and hopefully it'll find this item number 5 here, and it's going to give us the information. And then we could, depending on what we're trying to do here, we could say something like, write me a short product description for a product listing page like this, and it'll go ahead and do that. And you can imagine that, of course, now we're using a chat interface again, but you could imagine that you could have this built into a workflow where you're just listing through all the products in your database and just using the same prompt that you've worked on to get product listings, and then you can update your product listing view based on that. So let's take a look at how we actually make this happen. What's kind of the key part here is this default tools that we pass into the builder. So we're saying that these are the tools that are available to you. The tools that I make available are in this product service that I've injected. So if we look at the product service, it's a plain Spring service. The only difference from a just plain Spring service is that I've annotated some of these methods with a @tool annotation saying what they're for. So you can think of these descriptions here, both for the actual method name and for parameter names, as like mini prompts, if you will. So again, be very specific and in kind of how these should be used and what kind of values you expect to get into them. So in this case, we're saying like finds a product by its ID, and this is the ID for the product to find, and so on. So with just that, and then passing that product service in as default tools is going to allow the LLM to call these methods. So that's a very powerful pattern, and you can imagine that having this ability to give the LLM access to both reading and writing stuff into your system can be super powerful. The thing to note, though, is that especially for something where you're like modifying your system, like you should definitely have some sort of programmatic checks in what's actually happening, making sure that the right people are editing the right kind of things in the right way, so you're not getting any kind of weird stuff happening in your system. All right, good. Let's keep moving. So the last thing that we're going to look at is a RAG chat. So RAG means retrieval augmented generation. What it really boils down to is this R, the retrieval part. So what we do in RAG is that whenever a user asks us a question, we try to retrieve as much kind of relevant information to answering that question as we can, and then passing that along to the LLM. So it essentially kind of boils down to giving the LLM a open textbook test where we ask it a question, but we also give it the textbook that explains that specific concept open on the right page. So it makes it really easy for it to learn new things. This is specifically useful when you're working with data that a model hasn't been trained on. So this would be company internal data, stuff that the model just wouldn't know from before. So in my case, I have a little piece of documentation here from the Spring AI documentation about retrieval augmented generation. And this is stuff that was released just fairly recently, like 2 weeks ago or so. So this is not something that the LLM would be trained on. It wouldn't be something that it knows anything about. So if we were to ask some specific question about, let's say, the question answer advisor, tell me about this. So if we don't give any context to the LLM, it's going to think for a while, and then it's hopefully going to give us an answer, but the answer is going to be apparently a fictional or niche term. There's no widely recognized product, service, or entity by that name as of October 2023. So it tries to answer. Fortunately, it doesn't try to just make up a whole lot of stuff, but it's not very helpful in our use case. So what we've done here instead is we added a little thing where we can add some context, again, using the same upload component. We're going to pass in the PDF here. And now that we have that PDF as a context here, we should be able to, let's just copy this whole text here and then ask it to tell us about the question answer advisor. So hopefully now what it's able to do is use that document as a foundation for answering. So now it knows that it's a component used in a retrieval-augmented generation system. It functions by querying a vector database, doing this and that. So now it's actually able to refer to the documentation and give us a very specific answer related to our interest. So the way we've implemented this is using exactly this new advanced reg functionality in Spring AI. And that kind of boils down to a couple of different steps. So again, we're still using the same chat client. I've added in the builder a couple of kind of high-level things that I wanted to have. So first of all, I've added a message chat memory advisor. So this is going to help retain the message history as we're chatting back and forth, because an LLM on its own is completely stateless. It doesn't remember what we said a minute ago if we don't specifically include that in our prompt. So what's interesting here and kind of how this works is we've defined a few steps. These are not all necessary. I've added and documented them here so you can kind of play around and see which ones you might need. The most important one really is this document retriever, which uses a vector store to fetch relevant documents. But we're adding a couple of steps here. So pre-retrieval, we have a compression query transformer that rewrites the question. So sometimes, especially when we get to follow-up questions, the question itself may not be kind of useful in and of itself for us to help find the right documentation. So say a user might ask something like, what are the benefits when you're in a discussion around exercising, for instance? What this would do is it would look at the message history and it would rewrite that question into a standalone question, which would be like something of the form like, what are the benefits of exercising? Which again would be more helpful for us to be able to use to pinpoint that answer in a vector database. We also have a rewrite query transformer defined here, which will optimize the query for, in this case, a vector search. So for instance, let's assume the user has made a very kind of verbose and question like, oh, I've considered starting to run, maybe we'll lift weights, are there benefits to this and that? And again, if we try to search that long and kind of rambling query from a vector database, it wouldn't probably give us a very specific answer because it's formulated very differently from what it would be in the vector database. So this rewrite would probably, again, get us something that's more close to what are the benefits of exercising, which again would be probably something that's closer to what we find in our documentation. We could also add a step where we expand the query, where instead of just asking, like if the original question here is, what are the benefits of exercising? We might want to broaden our search to find things that are kind of related to that, give us a wider set of documents to work with. So this would essentially look at that, and then it would try to come up with queries that are related and that could help bring more relevant context in. And so it might add a couple of new queries, like what are the benefits of cardio? What are the benefits of strength training? And then we would go and search our database for all three things and then kind of add all of those documents to the LLM query. Then when we have this query, we go to the vector store or vector database to find relevant documentation. And once we have all the documents, we use a contextual query augmenter, which essentially takes all those documents and the original question and just builds one prompt based on those. So quite a lot of steps. Like I said, you don't need all of these, but I tried to kind of comment all of these so that it's easy for you to figure out which ones you need. I would keep an eye on the Spring AI docs because they're adding a bunch of more steps here, which will make it easy for you, for instance, at this point when you have a bunch of documents to figure out, right, we searched 8 different things and we have 20 documents, which are the 5 most relevant documents for answering this question. So you could kind of do a broader query and find lots of data and then just pick out the most relevant things out of that kind of pile. The final thing I want to show here is how we actually handle that document processing, which ends up being very straightforward. So we have a vector store, the same one we queried, which is injected here. And in my case, my vector store here is configured to be an in-memory vector store. But if you had added, for instance, the Spring AI Pinecone or other actual vector store dependency, you would have a vector store already injectable there. So we have a vector store, and what we do is we get the resource we get from the upload. So in this case, the PDF document, we pass it through our Tika document reader, which reads that into text. Then we give it to a token text splitter, which splits that into kind of reasonable sections. And then for each one of those, we run it through an embedding model to get a vector value that represents its meaning. And we store those in our vector store. So essentially a one-liner split into 3 lines. And once we've done this, we are then able to query our vector store to ask, like, hey, what are the most similar documents you have to this particular thing? As promised, you can find all of these examples, the whole project, in my GitHub under Practical AI in Java. So you can either scan the QR code or just navigate straight to the GitHub and you can find it there. If you have any questions, you can, of course, file an issue if you find anything there. If not, I would very much hope that you reach out to me if you have any questions, comments, anything that you'd like to see from me in the future. You can find me at Marcus Hellberg on most places. Thanks for watching, and I hope to see you at an event down the road.